Hello students, Ms. Slyman here, the day we've all been waiting for, I'm sure, thinking about inverse trig functions. So really we've been thinking about inverse trig values a lot. Anytime we end up solving an equation and we get something like sine of x is a half, well really we've been thinking about our unit circle, short angle, but really what we're doing is calculating the value of sine inverse of a half. So what is the angle if the ratio is a half? So let's just think about our unit circle and our sine values. We know that at 0, our sine value is 0. At pi over 4, our sine value is root 2 over 2. At pi over 2, our sine value is 1. And then we go 3 pi over 4, and we're still positive. And then we hit pi, and we're back at 0, and then we go negative. So remember that the inverse is when I switch all my x and y values. I can also think of the inverse as being the reflection over the line y equals x. So pi over 2 is about let's calculate it exactly, or not exactly, approximately, but 1.57. So this is about 1.5. So then 1 is going to be sort of around here, negative 1 sort of around here. So negative 1, 1, sorry, 1, 1, negative 1, negative 1. We go through 0, 0. So here's our line of reflection, something like that. But it's really hard for me to think about reflecting this curve over this line. So instead I'm going to think about plotting inverse points. So remember, I'm switching all my x's and y's. So really what we're saying is that now these are our new x values. Let's go with, maybe let's go with hot pink. So in our inverse, these are the new x values, these are the new y values. So this y here is our sine inverse of x. All right, so our sine x values are going between 1 and negative 1. So this is going to be my domain limits between 1 and negative 1. And now I'm going to get all of my angles. And remember, we could just keep going around the circle. So when we flip those, we get 0, 0. Root 2 over 2, let's calculate that value. Root 2 over 2 is 0.7. So when my angle is pi over 4, so let's do that one also. Pi over 4 is 0.78, so I get my x value is going to be about 0.7, my y value is going to be about 0.8, so 0.7, 0.8, something up here like this. When my x value is 1, my y value is pi over 2, so I've got 1, and then up here something at like 1.5, and then I'm going to start coming in. So I've got this curve here, and then it's going to start coming back. And then down here, I'm going to start having my negative sign values. So I'm going to cross and come up this way. So I've got my curve, but now it's climbing up the y-axis. So remember, my y values are now the angle values. So I can keep going forever and ever. I can keep going the opposite way as well. I'm going to come down and hit and then come back. So thinking about when I'm hitting my zeros, down here this would be negative pi, up here, so I should have come much further because really this value should have been much further down. I should have been past. So let's get rid of that. That's going to be much further away. So down, I'm going to come sort of around here because that value of negative 1 happens at negative pi over 2. And then down here we come back and hit at pi. So thinking about, is this a function? Well, if we limited the domain, sorry, not the It's not a function because we can go around and around the circle. But if we think of only going with our y values, if we think about only going once around the circle, even then we'd hit 2 x's. So we'd really have to limit it to make, we'd really have to limit our original to make the inverse a function. So if we limited the original to just go from pi over 2, negative pi over 2 to positive pi over 2, I would hit only once and have a function. But otherwise, I do not have a function because the graph ends up climbing up the y-axis. Yeah. So we could restrict the domain in many ways. The most common one is negative pi over 2 to pi over 2. So if we do that restriction, here's our inverse graph. Sorry, this is the original graph, so we're going from our minimum to our maximum. And then now our x's and y switch, so negative 1 to 1, negative pi over 2 to pi over 2. So sine graph, inverse. When we do the inverse, the domain and range switch. Okay. I still think in so many ways it's easier to think about the unit circle than the picture for solving these examples. Yeah. So where is sine root 3 over 2? I'm still going to think about, that's going to be a tall angle. Tall angle is up here, tall angle is up here. So I'm going to get pi over 3 or 2 pi over 3 plus 2 pi